Good afternoon, everyone. Today, we're going to break down exactly how a compressor works and look at the various systems that protect it. I want to draw your attention right away to the most important point here. A compressor is not just some simple kind of gas pump. This is a complex piece of industrial equipment that operates under extremely high temperatures and intense pressure, and it is very sensitive to operating conditions. If any issue or malfunction is detected, the compressor will either fail to start or will shut down. Today, we will be carefully examining the detailed operation of the compressor and its essential safety systems using a real diagram from one of the ships. We already know the general principle quite well. We thoroughly discussed and analyzed all the specific points and all the individual stages in our previous video. Now we take the vapor, specifically the boil-off gas, from the storage tank and we steadily increase its pressure to the required level. But if we compress it all at once, the temperature rises sharply, which is why a two-stage system with intermediate cooling is used. In the very first stage, the gas enters the suction and goes into the cylinder. Compression occurs, the pressure increases, and along with it, the temperature also rises. At the outlet, we get gas at a much higher pressure, but it is already quite hot. That is exactly why an intercooler is installed between the stages. Here, the gas is cooled, its volume decreases, and the load on the second stage is reduced. If this is not done, the second stage will overheat. After the cooling process is finished, the gas moves into the second stage. Here, the gas undergoes a recompression, and the pressure rises to the level required for condensation. At the outlet, we get very hot, high-pressure gas. Now let's talk about how this process works in practice. So, what important systems do we have that safeguard and protect our compressor? Well, the very first one to consider is low suction pressure. The compressor may start up and then immediately shut down. A very common reason for this is a lack of gas supply. For example, after an ESD test, someone might have forgotten to turn on the hydraulics. Additionally, the steam valves on the tanks are not open. Accordingly, if there's no suction, the compressor won't start. In cases of excessively high pressure, if there is high pressure in the tank, the compressor can also initiate its operation only to immediately shut down again. To prevent this from happening, a specialized automatic control valve is installed, which partially closes to effectively stabilize the internal pressure levels and then gradually opens by itself once the pressure in the tanks has fully stabilized and dropped. If there is no automatic valve, then this is done manually. At first, the valve is partially closed, and after a certain period of time, when the pressure in the tank drops, the valve is gradually opened, and finally it is opened fully to a full 100% capacity. What else might we encounter in this scenario? Pressure increase at the second stage. If the discharge pressure rises significantly at the second stage, the compressor will automatically shut down when this pressure reaches 15 bar. There can be several main reasons for this issue. First, the gas is not condensing properly, and as a direct result, the internal pressure increases rapidly. What can we do in this situation? We can vent to the mast or back into the tank. And the second point is a lack of condenser cooling. Here you need to check either the seawater or the flow, because it could be one or the other. Next, problems with cooling. This is a very important and critical point to consider here, because the compressor system is highly dependent on effective cooling. If there is no seawater, the compressor will stop. If the glycol cooling system continues to operate without any seawater cooling, it will eventually be forced to shut down. Once the temperature reaches a level of approximately 50 degrees and above, it automatically trips the system. The compressor will stop and will not operate. If, on the contrary, there is no glycol, the compressor won't even start. The system actually prevents you from starting it up. Now, you might be wondering exactly why that is the case. The glycol system is specifically engineered and carefully intended to keep the compressor at a very specific temperature, so that, for example, in certain conditions, condensation does not begin to form inside the compressor itself. This is a very important point. And if the system also has two safety systems. The first is temperature and the second is flow. That means if there is no flow at all, the system will also detect this. As a consequence of this, The compressor also will not be able to start up, so this aspect must always be monitored and checked as well. Regarding the presence of non-condensable gases, during cargo operations it is not always possible to vent these non-condensable gases to the mast. In a situation like this one, you can open the bypass and return it back to the tank. This will allow us to effectively stabilize the internal pressure levels. On the second stage, the pressure will not rise above the set value, and the valves we specify will regulate the release of this pressure back into the tank. As a general rule of thumb for this process, they are set to open and close at certain specific points. Let's say we want the valve to open at a level of 9 bar and to close at 6 or 7 bar. The valve will automatically discharge into the tank, and when we navigate out into the open sea, the system can then be switched over to its normal mode. We vent non-condensable gases out to the mast, and the system switches back to its standard operating mode. The most dangerous thing for our compressor is the accidental ingress of liquid into the compressor. That is exactly why the suction drum, which you see in the diagram, is provided. The compressor is designed only for gas. If liquid accidentally gets into the compressor during operation, or if there is a liquid sitting there and somehow you manage to start it up anyway, then that would be very bad for the machine, and here is exactly what would happen next. There will be a hydraulic shock, the valves inside will be damaged. I think the compressor will fail. So basically that is pretty much all I wanted to say for today. Maybe I forgot something along the way. Feel free to correct me in the comments below. Which specific systems did we discuss, and what are the systems that protect the compressor? Monitoring the temperature and the pressure, controlling the suction oil, and installing a separator unit before the compressor. This is our suction drum, protecting us against liquid carryover. All of these measures work together to prevent accidents. So all these compressor protection systems are absolutely essential for operational safety. To summarize the process briefly, gas is compressed in 2 distinct stages. Thoroughly cooled between these stages, and the sophisticated system constantly monitors all pressure, temperature, and flow conditions at all times. That's basically it. Thank you so much indeed for watching. I truly hope this video was helpful and informative for you. So I would be very glad if you could hit the like button, and I'm already happy if you watched the entire video all the way to the end. Thank you very much. See you next time.